Hey everyone, so there are a few things. This is going to be continuing matrix multiplication. But there are a few things I forgot to discuss in regards to matrix addition quickly. So this is 8.4 matrix operations continued. So in dealing with matrices, we can have all zeros as indices. So we could have a 1 by 1 matrix, it's just a 0. We could have a 2 by 2 that would have 4 zeros. We could have a 3 by 3 that would have 9 zeros. This, as you may have guessed, is just called the zero matrix. And we write it as, you can also have, this is also a zero matrix. So it's written just as 0, and it takes whatever size you need it to take. So if you had, say, 1, 2, 3, 4 plus 0, this would just be adding a 2 by 2 of zeros to this matrix. So this would be 1, 2, 3, 4 plus 0, 0, 0, 0. If you had, say, just a 1 by 2 with 1, 2 plus 0, this would give you just 1, 2 plus the 1 by 2 matrix of all zeros. It's not a very difficult concept to think about. If it's 0, it's just all zeros. But this does tie into something important that will come in for multiplication. And also brings us to our addition properties that hold for matrix addition. So if A, B, and C are matrices, then we have 4 different properties. We have our commutative property, which is that A plus B is equal to B plus A. We saw actually, well, this will be posted, viewed the 23rd, so we saw in a previous video that commutative property doesn't actually hold for multiplication. So commutative property is specific to addition and subtraction for matrices. It does not hold under multiplication. Second one is the associative property, which is that A plus B in parentheses plus C is equal to A plus B plus C. We have the additive identity. Now the word identity is important. It means that whatever operation you're, I don't want to use the word operating under, but literally whatever operation you're operating under, the identity will give you back the same thing. So A plus the 0 matrix just gives you back A. So 0 is our additive identity for matrix addition and matrix subtraction. And then we also have the opposite identity, which is that we need to be able to get to, so this is asking for the two things that add to 0, which would be A, and its opposite, which is just negative A. This is the scalar multiplication of negative 1 by A, so that will make every entry of A opposite. So if I had 1, 2, negative A would be negative 1, negative 2. Adding these together would just give me 0, 0. So A plus negative A equals 0. With that said, we can move on over to some examples for matrix, or I shouldn't say some, but more examples for matrix multiplication. And I said I was going to write things out a little more formally. So if we were to say I'm going to do something I love to do, which is just the 1, 2, 3, 4, 2 by 2 matrix. It's always like my go-to. And then B as the 4, 5, 0, 1. This is what we had done at the end last time. Yeah, we did this at the end last time. So we look at if I had A times B. We look at the rows for first matrix, in the columns for the second matrix. So step 1, this is just a general statement. Step 1 would be look at A row 1 and B column 1. Then we add A11, B11, so the product of those two first entries, plus A12, B21. If we had more, this could keep going. So I'm going to write this in a different color to show that it may not be this case. If you notice, the outside numbers are not changing. They're staying the same. So this next one would be A13, B31. So this is like how we have to have when I talk about order and multiplying. We have to have the inside numbers the same. So this is kind of becoming like that. We have the inside numbers the same. We have the inside numbers as 2 3s, and they're the same. The outside numbers right now just happen to be the same, but that will change. And then this would keep going to, say, A1N, BN1. From here, we then go, once we finish all that, we then look at, oh my gosh, at A row 1, B column 2. So then this one, I should say, is going to give me A, B, 1, 1. So since I have row 1, column 2, this is going to give me AB 1, 2. So I'm now in row 1, column 2. So this would be add A, well now I'm still in row 1, but I'm in column 2. So A1, 1, B1, 2. Remember, the first number is a row, so A11 is row 1, column 1. B12 is row 1, column 2. So I'm looking at this 1 and this 5. Then I would do, and if I look, I still have 1 and 1 the same. So now I'm shifting over in my row for A and shifting down. So I'm going to have A1, 2 times B 2, 2. So A1, 2, here's row 1, here's column 2. So this is 2, so this is A1, 2, row 1, column 2 is A2, B2, 2, so that's going to be B row 2, column 2 is A1. So I'm actually going to step back real quick, and I'm going to write what we have so far. So from the first one, we had 1 times 4 plus 2 times 0. So that took care of this first part. Now we have 1 times 5 I'm going to scroll over a little bit, plus 2 times 1. So I've now finished row 1 of A. You were always doing the row first. So you do every column in B for row 1. Then you finish row 1 and you go to row 2. So now we would look at, keep writing A's instead of O's. So A, row 2, B, column 1. So now this is going to be going into AB 2, 1, which is row 2, column 1. So I'm going to have A, I'm in row 2, column 1, times, this is B, column 1, sorry, row 1, column 1. My inside numbers still match up. So at first I'm looking at 3, that's row 2, column 1, and 4, which is row 1, column 1. We then would have A, 2, 2. So I'm going from 3 to 4. I'm now going to go from 4 to 0. So B, 2, 1. My inside number is still the same. My outside numbers are still 2, 1. They will always be 2, 1 for this row, or for this step. So here I had 3 times 4 plus 4 times 0. Then we would look at A, row 2, B, column 2. So this is going to give me A, B, row 2, column 2. So my outside numbers are always going to be 2 and 2. So I'm going to add, so 8 is add. So I have A, 2, I'm always starting at 1, and B starting at 1, 2. So that would be 3, that's row 2, column 1, and then row 1, column 2 is 5, so I have 3 times 5, plus, now I need to increase my inside numbers so they stay the same, A, 2, 2, times B, 2, 2. The inside numbers match, so we're good. So I have A, row 2, column 2 is 4, times B, row 2, column 2 is 1. I've now completed everything for this step, so then I have constructed the sums for my matrix. If I were to solve, as we did yesterday, this would be 4. Then we'd have 1 times 5 plus 2 times 1 is 7. Then 3 times 4 is just 12. Plus 15 plus 4 is 19. Alright, so let's just look at another example. say 1, 0, 3, -2, 1, 4 times 1, 2, 3, 1, 4, 2. And it's going to make 2 other layers. Okay, so I just made some references for us so we know what we are looking at. And I can actually completely highlight these and be fine with that. So right now, if we look, we have a 2 by 3 matrix and a 3 by 2 matrix. The inside numbers are the same, so we can multiply these, and it's going to yield a 2 by 2 matrix. So we always start with row 1, column 1. So for here, we have the first entry is a 1 times a 1. So this is 1 times 1. Then we are doing the sum. So this is plus. I have a 0 times a 2. Then the sum, 3 times 3. So now I can keep moving this over. So once I'm done with row 1, column 1, I change my column index first. So now I'm going to be looking at row 1, column 2. I can actually do cycle layers. That'll be easier. So for here, I'm going to do 1 times 1 plus 0 times 4 plus 3 times 2. So I've now finished everything in row 1, column 2. So I can now change my row to row 2. And change my column back to column 1. So now I'm going to do the same thing I was doing before, but with row 2. So this will be a -2 times 1 plus 1 times 2 plus 4 times 3. So I'm working from the leftmost and the topmost to the rightmost and the bottommost. Each entry is matching up. If I were to rotate this row into a column, or even this column into a row, I would be able to line them up. So I would say have -2, 1, 4, and then multiply them across as an example. We can then switch to row 2, column 2. So looking at what is in blue and red now, we'll have -2 times 1 plus 1 times 4 plus 4 times 2. The last step is just to simplify. So we have 1 plus 0 plus 9. We have -2 plus 2 plus 12. We have 1 plus 0 plus 6. We have -2 plus 4 plus 8. So I have 10, I have 7, I have 12, and I have 10. We can keep expanding these if we want to. So I could do, I'm now going to move my column over. So I have new space, and then go move my row over. So I have new space. I'm going to give this a 2 by 3 and a 3 by 3. So I would have a 0, a 3, a -1, a 2, a 4, and a -2 to move my row back up. And then I'll have in my columns, or my B, I'll have a 4, -1, 0, 3, 2, -1, and 0, 1, 0. Now for here, the process is again going to be the same. We're just going to have, if I erase this really quick, we have a 2 by 3 times a 3 by 3 matrix. Our inside numbers are the same. So we're then going to look at the outside numbers. So we're going to get a 2 by 3 matrix for our result. We're going to start with row 1, column 1 of my new matrix. Remember, I always do row 1 and all of the columns, and then switch to row 2. So I'm going to have 0 times 4, which I'm not going to write. Then I would have 3 times -1, plus -1 times 0, which I don't need to write out. This is just 0. I'll write out that the first one is 0. That way we know that's at least the third thing. So I had 0 times 4 is 0, plus 3 times -1. Then we're going to switch our column over. We're going to have, in this case, 0 times 3 is 0. 3 times 2 is 6, so plus 6. -1 times -1 is 1, so plus 1. I'm going to move my column over again. I'm going to get 0 times 0 is 0, plus 1 times 3 is 3, plus 0 times -1 is 0. I've gone through all the columns for row 1. So next I need to move my row down and move my column back to column 1. So from here, let's make sure I'm in the right layer. I'm going to have 2 times 4, which is going to be 8. I'm just going to skip the multiplication and write it out. So this is 2 times 4 is 8, plus 4 times -1, so that's actually going to be minus 4. And then -2 times 0 is just plus 0. We can switch my column over. I'm going to have 2 times 3 is 6, plus 4 times 2 is 8, plus -2 times -1, so that's going to be plus 2. So now I can move my column over again. And once again, we're going to have 2 times 0 is 0, 4 times 1 is plus 4, -2 times 0 is plus 0. So all that's left to do is complete the sums. So I'll have -3 in this first one. I'll have 6 plus 1 is 7. I'll have 3. And then I'll have 4. This is 14, 16. And 4. Alright, we're going to do one more example and then discuss the properties. So I have my first matrix, which is a 3 by 3. I'm going to make another 3 by 3 matrix. So we have our inside as the same. So our result will be a 3 by 3. So in the end, I should have a 3 by 3 matrix. So I'm just going to do this as 1, 2, 4. This will be 2, 0, 6, and negative 1, 1, 3. So I'm going to again start with row 1, column 1. So I'm going to have 3 times 1 is 3. I'm going to have 1 times 2 is plus 2. And a half times 4 is plus 2. I can then shift my column. So I'm going to have 3 times 2 is 6. Remember, we are looking at the first entries, then we look at the second entries. So plus 1 times 0 is 0, and plus a half times 6 is 3. Now we switch to the last column. We're going to have 3 times negative a half. I'm actually going to go change this really quick. This is going to be a 2 for the sake of simplicity for dealing with a half. So we're going to have 3 times negative 1 is negative 3. 1 times 1 is just plus 1. A half times 2 is plus 1. We have finished all 3 columns in B. So we will go back to column 1 and go down to row 2. And now we will repeat this process looking at row 2, and then column 1, 2, and 3. So now we have entry 2, 1, so negative 2 times 1 is negative 2. 3 times 2 is a positive 6. 0 times 4 is 0. We switch to column 2. We will get negative 2 times 2 is negative 4. 3 times 0 is 0. 0 times 6 is 0. And then we switch to column 3. We'll have negative 2 times negative 1 is a positive 2. 3 times 1 is a positive 3. 0 times 2 is 0. And now we shift our column back over to 1, and we shift our row down to row 3. And then we repeat the process. So negative 1 times 1 is negative 1. 2 times 2 is positive 4. 4 times 4 is positive 16. Then we can shift our column right, so we increase that column. So we will have negative 1 times 2 is negative 2. 2 times 0 is 0. 4 times 6 is plus 24. And now we can shift our column one last time. We're now in row 3, column 3. So this entire time we've been working in row 3. So in my answer matrix, I've been working in row 3. Except here, we're going to have negative 1 times negative 1 is a positive 1. 2 times 1 is a positive 2. 4 times 2 is a positive 8. And all we need to do now is do the summation. So we'll have 3 plus 2 plus 2 is 7, 6 plus 3 is 9, negative 3 plus 1 plus 1 is negative 1. Row 2, we have negative 2 plus 6 is 4. We just have negative 4 and 5. And our last one, we have negative 1 plus 4 is 3 plus 16 is 19. Negative 2 plus 24 is 22. 1 plus 2 plus 8 is 11. So this is our final answer, or our final matrix for that problem. So our properties for multiplication. In this case, we need a lot more things defined. So we have A, B, C are matrices. And then we also need to have AB, so A times B, A times C, and B times C. We also need A plus B, A plus C, and B plus C to all be defined. In other words, their order matches up. So our first property for multiplication is the associative. So A times B, all times C is the same as A times B times C first. Then we would have distributive. So here we'll have A times B plus C is equal to AB plus AC. I'm going to walk through those super quick. For the associative, if I had a 2 by 3 times a 3 by 2, then times a 2 by 2, 2 by 2 is fine. I could do this one of two ways. I could do A times B first. This would give me a, well, the 3's match up. So this is a 2 by 2 times a 2 by 2, which is just a, they match up again, so this is a 2 by 2. In the other case, I would do B times C first. So this would be a 2 by 3 times a 3 by 2. Our outside numbers are new order, since the inside match up. And in this case, our inside matches up still. We still just have a 2 by 2. I'm going to give a problem on Friday, just one, to work with the associative property. So you'll have to do really 3 multiplications. You'll have to do the left side and then do a problem with the right side, just to show that the distributive property is true. Again, I'm going to be on all of tomorrow and pretty much all of Friday. If you need any help with anything, whether it be this content, I should say all of today and all of tomorrow, because you're probably watching this tomorrow. So if you need any help with any of the content, please just stop on by the video chat and I can walk through more problems or answer any questions that you have.